of Lisp is available. If you look at the Lisp is coming under functional programming, and in the functional programming there is no control structures. We have to solve the problem using only functions. That means we will be dealing with the recursive functions. So using recursive functions we can able to solve the problems. And also there are some terms we discuss like composition. What is meant by composition? Composition is nothing but an expression in which the leftmost will be the procedure. For example, plus 2, 3. Plus 2, 3. So what is that? Plus is the procedure and 2, 3 is the operand. So plus is the primitive procedure. And for each primitive procedure, we have a corresponding machine instructions. Vikash, you're raising hands. Okay, so we discussed about the procedures, primitive procedures. So plus 2, 3 if you take, plus is nothing but a primitive procedure for which the equivalent instructions are already defined in the interpreter, and the interpreter knows how to take the arguments, how to apply the arguments to the procedure. So if you take this plus 2, 5, and you have an internal procedure interpreter, what it does is what is this one? This plus is what the corresponding machine instructions are what. So it will read it and then apply the operands and then evaluate and returns the result. Okay, if you look at so far, there are no return statements if we are talking about the functions. Okay, so let us look at that one soon. Now, right, we were in procedures, right? So let us take a syntax of the procedure. Can you see the PPT? Sorry, PDF. Can you see the PDF here? Students? Can you see a PDF here? Please respond.
Yes, ma'am.
Yeah. So how to define a procedure? This is a very primitive one. Define is the keyword, then name of the procedure, then formal arguments and body. Right. In any language, this is a one applicable. So define square of x, where the square is nothing but a name of the procedure and the x is the formal argument. Okay. And inside the body section, you can see here x into x. Right. So this is nothing but this is called as a procedure definition. Okay. And after defining the to call it, how to call it, the procedure name, and then pass the actual parameter. So what happens here? So the 4 will be substituted for the formal parameter x, and wherever that x is available in the procedure definition, the body of the procedure, it will be substituted and it is going to return a value. So now you just look at the syntax, define. Anyway, you have to start with the bracket and then define, and then you have to open the bracket, then give the name. So this is a syntax. You can't eliminate this bracket. You can't put a bracket for only the arguments. So procedure name and the argument should follow inside it should be written inside a bracket. So this is the way of writing the syntax and how to call it. So within a bracket, you are calling your procedure name with the value 4. Okay, so this is the syntax. And if you take this particular example, square we are calling. And if you are calling this square, we can also have a primitive value, that is a number, numerals, or you can also pass a composition. Okay, this composition, what is happening? It is evaluated and then that result is passed as the actual value. Okay, and it is substituted for the formal parameter. We can also call, we can have a nested function like this, see, square of 3. So what happens? So the internal, that is the inside what is the innermost one is the square of 3, it will be evaluated and the result is substituted as the actual value for this procedure. Okay, so this is another example, and yeah. Okay, let us take this one. Define. Example is a procedure name. And then what is this? What is this? Square of 8. It is nothing but an argument, right? So it will call the square and then substitute the value here. Okay, and you can just call the recent procedure. So here, what we are doing is we are in the primitive level, and a little bit we are going to the higher abstraction, and again we are going to the higher abstraction. That means if you look at this particular this particular statement, define example square 8. That means just to look at here, see the square is looking like it is a primitive or built-in procedure. Okay, so but you know that once it is defined, and in the further usage of this particular statement, and the user may feel that the square is inbuilt in. Okay, right. So these are all the few examples how to write procedures. Let us go further. Okay, so now let us define a procedure called x square plus y square. If you look at this is a very higher level. That means we need to do two operations. One is squaring of the argument, and then you have to sum it up, right? So there is no square built-in function is available, only plus is available. The interpreter knows only plus. Okay, so what are the structure? That means how to define a procedure which will be including the thing of including the abstractions. Okay, for example, here what is abstraction we want? We want a square. Okay, so define the square. Okay, and then define the sum of the squares. Okay, so now according to the given problem, x square plus y square, I'm just defining a procedure sum of squares. Okay, but what is the formal parameter? Is x and y, and inside the body you can say x into a, x into y, and these are added. So now we are getting x square plus y square. Okay, so this is one way of writing, but you can also write like this. Okay, that means you can build a small function square. That square you can also call it over here. Okay, so this is called as what is that? A complex procedure, I can say. Why? Because the procedure is the body of the procedure is nothing but calling another procedure. So I can say it is a little bit higher abstraction. Okay, so define sum of squares x, y, and then square x, square y, and both are added together. And if you look at the square x, and we have the definition for this. Okay, so there are two ways of writing this. This is a simple primitive composition. Okay, by using the plus and multiplication, we can solve the problem. Okay, but another way of looking at, we can also write it instead of x into x. You can also use the square x, where the square x is nothing but a function defined in your program. Okay, so we are a little bit moving ahead. As you know, what is this? See, something if you don't know with respect to the computer terminology, you don't know, but something is shown to you, and what is that? It is nothing. It is simple. Oh, this is the way. Yeah, that is what the actual thing happening in our world, right? So once you know something, it is nothing. But if I ask you, that is, do you know Lisp? I don't know. But if I show you this is the thing happening and this is the way of writing a program, then you said that, oh, I know Lisp, right? So that is the way. So we will move ahead. This is a small things we are helping you to understand how to write Lisp statements, expressions, procedures, etc. Okay, right. So now how to call the procedure, that is sum of squares are defined, and you can call like this sum of squares, and you can pass the number of arguments. Here if you look at the number of arguments x and y, and so that you can pass the two values. Now you will get the answer. That is fine. Now I would like to define another procedure, okay, and which will be calling the previous procedure. Okay, so going little higher level, define a function f with a value. The formal parameter is a, and if you look at the body of the section, body of the procedure, sum of squares a plus 1, then a into 2. right? There are two parameters. Sum of squares, if you look at, there are two parameters you want, right? Sum of squares, here what happens is a plus 1 is the first parameter, a into 2 is the second parameter. Okay, so let us call this one. So if I'm calling this function by passing a value 5, so what happens? 5 is substituted for a, and now if you look at 5 plus 1 is one parameter, and then 5 into 2, that is 10, is another parameter. So 6 is the first parameter and 10 is nothing but a second parameter. So can you tell me what is the answer? What will be the answer you will get? If you look at the sum of squares, there are two parameters x and 5, where x is nothing but now 6 is assigned and y is nothing but a 10. So what happens? What happens if you look at 6 square and 10 square? So 6 square 36, 36 plus 100, you will get 136, right? So now we know, actually you are not in the first year, I know. So now the thing is how to, see, you look at the style of writing the program. For see, if you are defining f is calling sum of squares, right? The sum of squares is calling what? It is calling the square function. So in this way, once you have a lower level abstraction, higher level abstractions can be built on top of that. Okay, so I hope that you understood how to define a procedure, how to call a function, and inside the body of the procedure, you can also call another abstraction. Okay, another function. Yeah, that is what we are trying to tell you. Okay, so now in list, how the expressions are validated, how the function is called, and when you are calling a function, actual parameter is substituted for the formal parameter, right? So there are many models available. Let us look at. Okay, the first one is the substitution model. So according to the substitution model, what happens? So let us take this particular same example. You have sum of squares. Sum of square is going to operate on two arguments, x and y, and if you look at the body of the section, you have x squared plus y squared. Okay, and if you look at the f is calling the sum of squares, and the sum of squares of a plus 1 and a into 2. Okay, now you are calling f function is called by passing a value 5 to the formal parameter a. So now if you look at internally as an engineer, as a computer engineer, you have to know the internal functions of the interpreter or a compiler. Okay, so now how the Lisp is going to act on it, okay, by this model, substitution model. Actually it is following a substitution model, but there are other models as well, it is available. Okay, so now according to this model, what the Lisp interpreter will do? Any guesses? Any guesses? What is the first step? You are calling F5. What happens next? What happens next? 5 is substituted for A, and the sum of squares of, and 5 will be substituted here. 5 plus 5, 1 and star 5, 2. It is substituted. And after substituting, what will happen? Any guesses? Students, are you there? Please interact, otherwise the subject will be bored.
And will evaluate the inner part.
Yeah, it will evaluate the composition and then take the arguments. That arguments will be once again passed to the sum of squares, right? So this is called as the substitution model. Okay, and now there are other models as well. It is available, and let us say something like. Now this is according to the substitution model, and we can say the order of applicative order. That means how the procedure is executed for calling f comma 5, and the first step is sum of squares of plus 5 1 and star 5 2. For instead of a, 5 is substituted, and then it is evaluated and calling the procedure inside. That is then again square x, square 10. Then square means what? You again define the function. So in the defining function, what happens? A into a. What is a now? It is 6. So instead of a, 6 is substituted, and here 10 is substituted in the expression. And then if you look at, finally you are getting your composition, nested composition, that will be evaluated. The interpreter now it knows how to evaluate this nested composition. Okay, this is nothing but a substitution model. Okay, that is our expectation. Our expectation and the Lisp interpreter, how it behaves is same, right? This is the way it will work. So the strategy, what is this? Evaluate the arguments and then apply. This is the strategy applied in the substitution model. So evaluate the arguments. So sum of square plus 5 1. It evaluate, please evaluate and then apply the value as an argument. If you look at this square of x and we substitute the expression and then evaluate the expression. Okay, so this kind of concept is called as evaluate the arguments and then apply. Okay, so next we go for the normal order substitution model. This is another method. How the function is called and what is happening inside. After all, it is not following a substitution model. Okay, let us see. So what happens is here, you are calling F5, okay, and F is calling a sum of squares. Okay, so F is calling the sum of squares and instead of A, 5 is substituted. Okay, now this will not evaluate. Okay, according to the previous substitution model, this is evaluated, but in the other case, what happens is it will just keep as it is, the compositions are kept as it is till all the values are known. Okay, till the procedure call is converted into a primitive expressions, primitive compositions. Okay, so now look at F is calling sum of squares and then it is substituted, A is substituted. And the sum of squares is calling the square function and the arguments are taken as it is not evaluated. And the square, what is that square? If you look at the square and once again plus 5 1 will be repeated. That in according to the definition, square of A is nothing but A into A, right? So this parameter, if you look at as it is substituted. As it is expanded. Square of 5 into 2. So 5 into 2, it is as it is carried on to the next level. And finally, the interpreter evaluates the complex compositions, nested compositions. Okay, so now comparing with the normal order substitution model and the applicative order substitution model, what we define, if you compare, can you tell me which one is better? In the previous case, this is evaluated. Arguments are, as soon as the value of the arguments are known, the primitive composition is known, it is evaluated and then going further. But in the normal order substitution, what happens? It is not evaluated, okay, till the whole primitive is known to the interpreter. Okay, for the function called f of 5, and what are all the things you have to call, you call it and then substitute, okay, don't evaluate. Okay, evaluation will happen at the final step, right? So now, okay, so now you understood both models. So which one you will recommend? Which is best? Which is advantageous? Can you tell me, any one of you?
Ma'am, model because
which one you are saying?
First one, ma'am.
The first one is better. Okay, why? Because
in this one we'll have to remember everything. The whole expression has to be remembered until we reach the end. But in the other one, only the final value needs to be remembered. Like memory wise, this is the other one.
Okay, what about the computation wise? Computation wise, if you look at plus 5 1, see plus 5 1 is evaluated twice, right? So if you have evaluated the value here itself, you no need to repeat again, right? So see here 5 into 2. 5 into 2 is repeated twice. Twice, same you have to perform. So the computation wise, it is not efficient. Okay, so that the substitution model is very better. Okay, so provided substitution model, applicative order substitution model, and a normal order substitution model, the second method, and will you get the same answer? Will you get the same answer? Now you will get the same answer, but in some cases, while going through advancing in the language, sometimes both are going to give you a different answer that we will look at later. Okay, as of now you understand that there are two models available, and the first model is very efficient in terms of memory and in terms of processing power, right, computation wise. Okay, so now we know thoroughly the how to write a procedure, how to call a procedure, and what are the methods the interpreter will can take. Okay, so one is fully expand and then reduce. This is the second model, and the first model is evaluate the argument and then apply. Okay, so if you look at this normal order substitution model, what is the phrase? Phrase is nothing but fully expand. You are fully expanding and then reduce. Okay, so there are two models, right? So this is one we explained. So which one the Lisp is using? The Lisp is using the applicative order, the first model only. Okay. So far we have written a procedure and we didn't see any constraint. But the languages, we can feel that language is not providing any convenient structures for writing any logic. For example, if is very compulsory. If statement is required. Without if statement, how to write logic? Right? Simply defining a function and calling a function and defining a function inside a function, we can't solve, right? So the language, the Lisp is providing some facility, a kind of conditional expressions. Okay, so if you look at how to define the absolute value of x, okay, we can write like this. Absolute value of x is nothing but if x is greater than 0, it is x. If x is equal to 0, it is 0. If x is less than 0, it is minus x. Yeah. So this is the, I can say class 1, class 2 and class 3. Okay, this is a case analysis. So I can say it is a case analysis, right? So here for doing a case analysis, what is the facility available in Lisp? Okay, the Lisp must provide something. Okay, it provides cond. Cond is the keyword, and we already know define. Okay, so yeah, I would like to ask the question like define A10. Define A10. Okay, what is define? Will you call the define as a procedure? Okay, so I say another thing, plus 5-2, plus is a procedure. Okay, where the define A10, the define is a procedure? No. Okay, it is not a procedure. The define is a keyword useful for making a association. Okay, with the define we can make a small abstraction. Okay, define pi is 3.14 or define square as something, cube as something. So if you look at something, the something is nothing but a complex expression. You can have a composition, nested composition as well. Okay, so that the define is useful for defining an abstraction. It hides the value what is present in the variable. Okay, and in the list, with respect to the list, the variable is not at all a suitable word, but we have to use the name, right? The variable is nothing but a name. Okay, so now in this particular thing, absolute of the variable x, absolute of the name x. Okay, let us see. Okay, how to define this? The language is providing a cond. Cond means conditional. There is some structure available. You can very well use this. Okay, so if you look at the syntax, cond, P1, E1. P1 is called as a predicate. E1 is called as an expression. Predicate expression, it can be continued n times. Okay, what is meant by predicate? Predicate here, the Lisp predicate is nothing but we have to write a predicate in such a way that it has to return true or false. Okay, so now you can very well understand what it is. Condition and some predicate. If the predicate is true, it will evaluate E1. If it is not, it will go to the next predicate, it will check. If it is true, it will evaluate. So if it is true, what happens is it is evaluating the corresponding expression and then it is terminating, it is returning from the cond. Okay, so if it is false only, it will move to the next predicate and go on checking for the predicate values. Okay, so what is meant by predicate? Always the output of the predicate is nothing but true or false. If it is true, the corresponding expression is evaluated and then break from there. Okay, if it is false, then go to the next predicate, check it. If it is again false, go to the next predicate, and so on and so on. And finally, Pn is also false. Consider Pn is also false. So what happens is it will return you infinite. It will return you infinite. Please mute yourself, please. Somebody is talking. Muted. Okay, so this is the meaning of a can't. Okay, so predicates always return you true or false. If it is true, then the corresponding expression is evaluated and then return the value. Okay, the expression value will be returned. And if it is false, go on continuing the checking predicates. Okay, till the end. Okay, till the end, no predicates are satisfied. That is, it is not returning true. Then what will happen? It will return infinite. Okay, so whenever you are learning some constraint, please understand the whole concept. Here in list, what happens? So now, can you compare this cont to some control structures in a procedural language? What you can recall? What you can recall? Which control structure can be equivalent to this cont? Any one of you?
Switch, ma'am.
It's like a switch. Yeah, correct. So the condition, okay, the condition is predicate. The first condition is not satisfied, go to the second condition and so on. And whenever the condition is satisfied, the corresponding expression will be evaluated and that result will be returned. If nothing is true, it will return you infinite. That is a statement. That is a thing you have to note down, right? So now if you look at this condition, and usually in list I call it as a expression. P1 E1 is called as a expression, right? And this is called as a classes. The both together is called as a classes. Class 1, class 2, etc. up to class n. Okay. So now the predicators used for procedures that return hash t or hash f. What Lisp will do? Okay, it will evaluate and returns true. You will say T R U U UE, right? Or FALSE. That's what you are understanding, right? According to other languages. Here what happens is it will return you hash T. Hash T means the interpreter will assume that it is true. If it is written a hash f, it will assume that it is false. So what I'm saying is the predicate answer is nothing but hash t or hash f. If it is hash t, the interpreter will assume that it is true. Okay, so what is the value written by the predicates? What is the value written by the predicates? It can be hash t or it can be hash f. Okay, right. So let us look at if you are talking about the predicates, how to write a predicates. How to write it's all a combination of relational expressions, right? You can have a greater than symbol, less than symbol, and then equal. Okay, you can also ask me, can we write a logical expression by using and, or, not? Yes, it is also possible. Okay, so and or not, you can also use it. Okay, so now let us take this particular example. Define absolute of x. So what I have written in the mathematical form, okay, in the previous slide, this mathematical form, okay, this one can be written very clearly in Lisp like this. Defining absolute of x. How to define? This language provides can't, right? Can't, how to write it? You just see where the expression, the brackets, right? You are starting the bracket and then before the procedure name, another bracket, and before the condition are the bracket, and after the condition you have to write the predicate inside the bracket, right? So these are all the things you have to memorize and you have to practice. Okay, so can't x is greater than 0, x is equal to 0, 0 and x is less than 0 minus x. Properly close the brackets. This is very important. Otherwise, it will not proceed further. Okay, so it's all syntax error. If you are getting a syntax error, you can't get any value. That is, you can't get some output, right? Okay, so now we know how to use the cont. Okay, right. And let us look at another example for the same functionality. Okay, let us see absolute of x cont x is less than 0 minus x else return x. Okay, so what is that? Actually, see, this is the expression. The expression is here x. 0 is the expression, minus x is the expression. So now for the execution of this statement, what will be returned? X will be returned, or 0 will be returned, or minus x will be returned. Okay, right? So here in this case, what happened? We can straight away write x is less than 0 and it is minus x, and here else return x. Okay, that is no return statement at all in Lisp. Okay, as soon as the expression is evaluated, it will return the value of the expression. There is no return statement. Please keep in your mind. Don't use the return statement. Okay. We go for there is another useful procedure called as if structure is available. Okay, so we have a cont. Okay, but the language is also providing if you look at the syntax, if predicate consequent alternate. Okay, what is the meaning of consequent? You know what is meant by predicate. Predicate will always return you true or false. If it is true, go to the consequent, evaluate the consequent, and return the consequent. If the predicate is false, evaluate the alternate and return the alternate. Okay, that is the meaning. Okay, so same thing, absolute of x is defined like this. If x is less than 0, if it is true, return minus x. Yes, if it is false, return x. We can simplify the statement like this. Okay, so you can use a cont as well as you can go for a if, but there are differences. But so now if you look at the cont, okay, what is the flexibility given here? In the cont syntax, the predicate one expression, it can be any number of expression you can have, any number of compositions you can have here. Okay, you can have any number of compositions here. Even actually in the syntax we have written even, you can write any number of expressions. Okay, but in the if statement, only one expression you can write. The consequent should be only one expression. You can't return multiple things. Okay, that is the difference between if and cont. That you have to remember while writing the program. Okay, understood? So now let me ask few questions. The students are very calm and I don't know what is happening. Shall I call someone? Okay, I call Ashwin. Ashwin, are you there? Dinesh? No one is there in line. Why are you connecting? Students? Dinesh, are you there? Harshit? Saket Chandra? Yuvatej? Yeah, at least one. Yeah. Okay. So now tell me, what is the model the Lisp uses for while evaluating or while calling the functions and substituting actual value to the formal parameters? What is the model it adopts? There are two models we have discussed. What are they? Okay, I move on to, okay, a hint, substitution model, applicative order substitution model, and normal order. Hello, students.
Yes, ma'am.
Yeah, so which model the Lisp uses? That is my question.
Substitution model, ma'am.
Applicative order?
No, ma'am. Substitution.
Yeah, that is what, applicative order or a normal order? It's applicative order. Okay. Normal order is different. Normal order is the second model, what I taught you.
Yeah, yes, ma'am.
Okay. Let's go for a Prasanna. Durga Prasanna.
Yes, ma'am.
Right. How will you define a higher order abstraction?
Inside a method, we will call another function. Like inside a function, we'll call another function.
Another function you can call. So you can build based on simple abstraction by using the define keyword. That's what you have to say, right? Okay.
Yes.
Yeah. So let's move on to Krishna. Krishna, are you there? Hello, Krishna, are you there? I'll put absent. Oh, whatever. What is the meaning of putting absent present? Okay, Srinath. Srinath. Deepak. Any one of you, please don't be. Yeah, Deepak. So you learned some can't and if, right, in the Lisp language. What is the difference between can't and if? If. What is the difference between can't and if? When you will go for a can't, when you will go for if? Okay, students, please listen to my video or take your ebook, read it. Please read and